Okay. So this week is week 6. This one. Okay. So week 6. So our homework will postpone 1 week. So I'll give you the assignment on week 8.第8周会给你 homework. Right. But sorry, for the exam, I cannot postpone because if I postpone exam 1, the exam 2 will be too close to the exam 1. So the exam will be on week 10th. Week 10th here. So the same. 我们第一次考试是第10周考试这样子。Oh, sorry about that. So it will be week 10th, the same. So I continue. So how can we solve R3? It's based on the cross product of R1 and R2. Okay. But right now we have one problem is when you solve R1 and R2 or Rx and Ry, both are not orthogonal. That's the problem. That's meaning when you reconstruct the object, when you do the 3D reconstruction, suppose it's a cube, but after you reconstruct, it's not become a cube because it's not guarantee Rx, Ry are orthogonal. No. So how can we solve these problems? Will be used in the next page. So it's meaning how can we approximate making a orthogonal matrix of the rotation matrix? So it's this way. So suppose right now you have Q. Q is Rx, Ry, Rz, 3 by 3. If you have a Q, if you originally have a R is mean Rx, Ry, Rz. So 3 by 3 parameters. So how can you make sure all 3 axes are orthogonal to each other? You use a singular value decomposition, become UWVT or UZVT, and you just put Z become the identity matrix, and so the R will become U times V because in SVD U are orthonormal matrix, V are also orthonormal matrix, so you can get the orthogonal matrix. 我要讲一遍，你这个做出来以后，你的这3个，尤其是 R1 跟 RXY 是不会垂直的哦，常常不会垂直，因为它没有给人体垂直。所以你要恢复成垂直的话，直角坐标的话，你要把这个 R 就 R1、R2、R3 放在 R， 你经过 singular value decomposition 的话，会变成这样子。那因为 singular value decomposition 是 eigenvector 的特色是什么？是轴尾跟轴之间，它是一个 union， 就 orthonormal， 它是 orthogonal annihilation， 这2个都是 U 跟 V 都是，所以你就把 Z 拿掉 ，U 乘 V 就这个，就最后结果就变成垂直这样子。所以 you need to make sure they are orthogonal by using SVD. So this R is original R1, R2, R3. So it's 3 by 3 matrix. And then use a singular value decomposition, become U, Z, VT, and Z just become identity, this one. So the final result is this one. So after this result, you will make sure your result be Rx orthogonal, Ry orthogonal to Rz, okay, and also orthonormal normalization. So you solve it. But when we get the R is 3 by 3 matrix, How about the Euler angle for each？ 就是你得到这个轴，可是你知道它旋转角度吗？You got a rotation, but it doesn't know the rotation angle. You just know the parameters is 3 by 3. You doesn't know its rotation angle of Euler angle. So how can you solve it? You should use this one. Okay, I don't know how to pronounce it, this one. You should use this one. This one will transfer the 3 by 3 matrix become this result. And this result will has a Euler angle of Rx, Ry, Rz. And OpenCV have this function. So you just call this function, you input in the matrix, output destination will become this one. Just use it. So you will know the Euler angle. So the Euler angle and the 3 by 3 rotation matrix, they can convert to each other. Use this one. And the solution is here. But I don't describe the detail. So this Euler angle, theta, phi, and rho, this one. Okay. The 3 by 3 become Euler angle. You can use this one. 好，那这是解完了。好 ，So we solve the intrinsic parameters. We solve the extrinsic parameters. And finally, we need to solve the distortion parameters. So this one, distortion. Okay. So the distortion has two kinds of distortion. One they call radial distortion. It's because the lens is manually to use it or use machine to to do that polish that one. 你去磨它，所以它会有这种那种弧度的关系。So we have a K1, K2, K3, 3 radial distortion parameters. Okay. The other is a tangential distortion. That's meaning this is a chip. And then when the chip attached on this sensor, sometimes is not parallel to this result. There was some tilt. So they have two parameters we call P1 and P2. But also you just use it. 这5个参数 K1, K2, K3, P1, P2. Actually, you don't need to know the details. And you call the function, they will solve it. So I do the formula here. So you try to suppose you try to solve this. For example, you try to solve K1 and K2, and you know the parameters. Sorry, you know the point. So you do calibration, right? You know the points here. I copy to original one. See, there's some distortion here. Lens distortion. So, but you know the corner here. So based on the corner, and we want to make sure it's a flat. So we use the equation is right here. This is orange. This you don't need to. Don't worry about this one. Okay, but just explain to you. This is the original. So sorry, this is the after calibrate, and this is original. So this is distorted. This is distorted. 那这没有 distorted. And we try to solve the 5 parameters. So the solution will use pseudo inverse. So AX here is dk equal to d, capital D, k equal to d. So this one we use pseudo inverse. So this is pseudo inverse. That's meaning because d doesn't have an inverse, so you d times dt, and this also times dt. So you have dt in left hand side, dt in right hand side. This one. So you do the inverse here, so you solve k. You solve k. Okay. And all the calibration is based on this paper. I forget to tell you. Sorry about that. So all of the calibration in this lecture is based on this paper. And Zhang solved this one. And OpenCV has used this method but improved. So OpenCV has better result than this paper. He improved a little bit, but it's based on this paper. And my lecture is based on this paper because this is a good paper, good one. So we solve it. So one more page here. I forget to put this one on your slides. I forget it. So up to here, that's the linear application. So up to there is here. We solve it, and then we use either EM or LM to solve it. So which situation will use LM? If you have a ground truth, you have ground truth, you use LM. If you don't have a ground truth, you use EM because EM is expected maximization. So if you have for sum of square difference, if you have a ground truth B, you use LM. Sometimes you don't have a ground truth for the unsupervised learning, you will use EM. E is expected. What's expected? Expected average. So you got an average value. And what's the maximization? It's a maximal likelihood. So this is unsupervised learning. So E is expected, it means average. M is maximal likelihood. So you got the initial result because you don't have a ground truth. So based on the result, you try to have the average result. So it's called expected, and then maximization. This is called EM. So this one will apply, EM will apply to where? To reinforcement learning. Reinforcement learning use this kind of approach. 你在解那个强制 reinforcement learning 的时候，它是用到先找它的平均值 ，reward 的平均值，再做 maximization。是 unsupervised learning 用这个方式。那我们的 in our case, because we have a ground truth, so we use LM to this nonlinear application to solve this result, and we got a result. Okay, so after we do the calibration, so this camera, you know the intrinsic parameters. So if you use this camera to take the photo like this one, okay, and if you know the corner, and you can reconstruct the 3D. 这样子。After you know the intrinsic parameters, 你知道你已经算出了这支摄影机的 one camera has only one set of intrinsic parameters. You only need to calibrate one time. So one camera, any camera between each other has different intrinsic parameters. Any camera, after you calibrate its intrinsic parameters, that's it. You only need to calibrate one time, and you can use this camera, and you take the object, and if the object, you know the corner, you can reconstruct the 3D. So the same, if we do the volleyball or the court, if you do the calibration, after you do the calibration, and the court will become 3D. You can rotate the court in 3D view. So the 3D calibration. Okay. Now, then in chapter 3.1 is the experimental result. You can check by yourself. Okay, 这个就比较没什么，这个就是 paper inside the paper. Okay, finally, this one example. I show you this some amazing results. That's meaning in the new one is the new technology is if you take a photo, probably we can estimate the position you take the photo. 就是你如果照一张相，我们可能有办法把你的照相地方把它估出来。那这个不是this is not completely automatic, it's a semi automatic. It's meaning if you're in the internet, you collect all the data for this one, right? And then they can reconstruct the 3D of this arena. 它可以把这个弄出来，这不是全自动，有点半自动的。我实际上不晓得它怎么做 ，I don't know how they do this way, but in theory they can do that, so they can reconstruct. So each one is like an image, and based on the multi-view of image, multi-view of photo, and in the internet they can reconstruct this one. 最后把3D 整个呈现出来 ，OK。Point cloud, right? So after you have 3D, you have the point cloud, and you do texture mapping to become 3D. So calibration is very important. Okay. I say again, sometimes you use chessboard for the calibration, but sometimes if you don't have a chessboard, but you can use the AR things. Is meaning you can use like a plane. You should try to find a plane have a corner. Based on the corner, you can do the 3D reconstruction. Okay, so they can become 3D. Okay. So there's some example. And I'll show you more example about this one. This one. Okay. So this one example you can do. See this chessboard, right? So a chessboard here. So after you do the calibration, this chessboard, and you do the calibration, and based on the chessboard. So the important thing for the AR one, the most important one, you need to have a plan. 你要给它一个地 ground, sorry, you need to have a ground. So suppose this is a ground, and then you have a 3D model you can put on the ground, this one. So this is AR, okay? So AR should have a ground. The ground is the plane. I think one of the homework will do something like this one, but we'll teach you. So that's an application for the calibration. So you can do AR. So you will see a lot of AR in your cell phone. The other is let me check. This is the other application. 3D modeling, your mesh, so you can do some AR thing. Okay. So that human-computer interactions become like popular. So there are a lot of things you can find those in YouTube. So we go for next lecture. So next lecture we'll talk about stereo. I stop it here.